Hello everyone, welcome to the stream. I'm Jared, Rubyist. I've been doing Ruby for too long, 10 years, something like that. I run a company called Super Good Software where we build e-commerce software. We do some fun, agile software development. We use a platform called Solidus. Now every December, I solve Advent of Code problems, Christmas-themed programming puzzles. The next day 4 is about to go live in a minute and 10 seconds, and I'm going to attempt to solve it in Ruby. I usually use I do a little bit of RSpec, but unlikely that I'll do anything too exciting. I usually just use it to verify that my puzzles produce the desired result given the test input that they give us. So we'll see. Day 2 and 3 I did yesterday when I was extremely tired from having played hockey the night before, late game. No hockey last night though, so no excuses. Just a regular old Friday night. Yeah. Let's cut over to the code here. All right, day 4, giant squid. You're already almost 1.5 kilometers, almost a mile, below the surface of the ocean. It's nice translating for the Americans. Already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. Numbers may not appear on all boards. If all numbers in any row or any column of a board are marked, that board wins. Diagonals do not count. Let's see, if all numbers in any row or any column of a board are marked, sure. Submarine has a bingo subsystem to help passengers, currently you and the giant squid, pass the time. It automatically generates a random order in which to draw numbers and a random set of boards, your puzzle input. Okay, sure. Here we go. Wake up. After the first 5 numbers are drawn, 7, 4, 9, 5, and 11, there are no winners, but the boards are marked as follows, shown here. After the next 6 numbers are drawn, there are still no winners. Finally, 24 is drawn, and there we got a winner right there. At this point, the third board wins because it has at least one complete row or column of marked numbers. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on the board. In this case, the sum is 188. Then multiply that sum by the number that was just called when the board won. Start by finding the sum of all unmarked numbers on that board. In this case, the sum is 188. Then multiply the sum by the number that was just called when the board won, 24, to get the final score for 4,512. To guarantee victory against the giant squid, oh, we're cheating. Figure out which board will win first. What will your final score be if you choose that board? Okay. I don't really need my puzzle input yet. We'll just start with this. Assume the puzzle input's going to be some enormous, yeah. Cool. Okay, with that. Oops. All right, we want to work on day 4, part 1. And let's open a nice spec here for day 4, part 1. So as usual, I am going to write a very simple spec. Day 4, part 1. The way I set these always up is I have a solution method. The subject here is describe class new. We pass in an input. I'll call solution on it. The input is going to be the text that we were just given. Ooh. I, however, did not actually copy onto my clipboard. It's going to be a recurring theme. Input. Okay. And that is expected to equal, what was our final? 4512. All right. Cool. Okay. Yeah, let's just spec this thing out. That is expected here. Oops. One number of arguments, we need a constructor that takes an input, and just want to be able to type today. Yeah, there we go. Probably should just take my work keyboard home. And it doesn't have a solution. Okay. I'm just gonna take a little gander at what we're doing in here. So input is the string, and I'm pretty sure that we can split on double new lines to get something useful out of that, right? Yeah. So we can do something like numbers, boards. Does this work? Is this a thing I can do? Input, split. Cool, that works. And then numbers is gonna, let's just split that on those commas and map those into integers, right? And then the boards, probably want to like construct some kind of objects here. Board new. What are we doing? Boards map. Let's map them. Not exactly great nomenclature, but that's fine. I don't know what we're gonna call this. So we're like split it on the new lines in there. And then we'll map each, those will be each rows. Row, and the row will need to split on any white space. White spaces /s. And we'll we'll map those to be integers too. Seems reasonable. So now we got some numbers, we got some boards. We're gonna want to do something with them. Guess let's just take a look, see if sort of broadly speaking working as we expect. So we should have numbers and we should have boards. So I kind of want to write some code that's like loop over the numbers, call the numbers on each board, yeah, boards each. I'm using call because it's not because of the Ruby convention, just because like you call a number in bingo, right? And what are we doing? Well, I got a break if boards any finished. And what are we calling this? This is the score. Something like that. That seems reasonable. So I guess we'll our spec by method numbers. That's good. All right. And I might have method call. Okay, and finished. Score. Okay, cool. So now it's erroring because it gets through all the numbers and all the boards, and none of them say they're finished, and tries to call score on nil. Okay, that all seems reasonable to me. Now I think this is where I need to actually have like a cell, right? Cell's got a number. Okay. Oh, and we're actually supposed to. Gotta keep track of that. Score, how we decide we're scoring this thing. sum of all unmarked numbers times the last called number. So we can do that. So this is just so reject called some number. Okay, and so now we kind of have everything except for whether it's finished or not. We can get rows pretty easily, which I think will make our test case pass here. So we do nums dot any row dot all called. I think that. What? Line 30? What's going on line 30? Oh, I never actually used the cell. Alright, map to I, map number, cell dot new number. Cool, so that works. That doesn't actually cover both cases. So we need to do or something like Ruby array method here that can help us. Ha, radar transpose. I think that works. Element size differs. 6 should be 5. What? No, I'm just not transpose. What is going on? Oh, something must be messed up with our board construction. Right? What's going on here? These are all 5 by 5. What are we dealing with here? If nums. So what do we do? So this does not equal 5 and nums dot all. not 5 rows. If any of these do not equal 5, let's look at this. Sure enough. And so the board we were given is 2, 2, 1, 3, 1, 7, 11, 0, and we got 2, 2, 3, 1, 17, 11, 0, and then in the next one we have, oh, gotta strip them too. Okay, it's easy enough. Okay. Strip the extra white space out. Let's just sort of reformat this. Sure. Sorry, what? Map. Oh, yeah, just call strip, not map strip. All right, okay, so that probably works. Now we can switch this up. So file.read data / day4.txt. Day4 part 1. Uh-oh. What do we got here? Is this right? Oh, what did I do? Oh, I probably did the same thing again. Didn't close my friend. Cool. All right, that works. Amazing. All right, let's do it. Part 2. Here we go. On the other hand, it might be wise to try a different strategy. Let the squid win. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to second board would have a sum of unmarked numbers equal to 148 for a final score of 1924. Yeah, okay. That makes sense. Once it wins, what would its final score be? Sure, yeah, we can do that. All right, so let's open up part 2. Wow. AOC, day 4, part 1. So we're just going to inherit from part 1. I'm just going to open day 4, part 1 down here. Yeah, let's open the spec file. Let's just start from where we were at, except now we're expecting a different answer. 1924. We can call it, and we should just get an initialized constant. Let's save that. Oops. Day 4, part 4. Oof. AOX? Where did I type AOX? Oof. Yeah, this is definitely turning into a demonstration of how I don't type on this keyboard normally. So what do we want to do here? Could probably reuse most of this. So I mean, we can do a little refactoring. I don't really know. I'm having trouble thinking through this. We can kind of do some refactoring and see where it gets us. So we want to like win like game over, maybe. So we should. Yeah, we're still just failing on one spec. In fact, let's just go mark that as pending. Cool. It's easy to distinguish if we've broken something. I don't know if this is useful. What do I do? So I'm trying to do this not, I mean, I guess I just do it in an ugly way, but I kind of just want to, I kind of like reusing the code between part 1 and part 2, or seeing what I can change to make that nice. I don't know, maybe it's not worth it. I guess I shouldn't try and refactor it prematurely. All right, let's just write a new solution. Start from this one and just get there. So we need the last number and last board. This is now all boards finished. Last board equals board if board finished. Is that it? Very close. Why is that not right? pieces off here. Oops. $148. How am I off by one? What's with these weird off by one errors? What does that mean? First, is this the right board? Is this supposed to be the second one? 315. This isn't the right board. Oh, what? Stop if all. I mean, it looks like. I'm getting the first one, not the second one. Oh, I see what I'm doing. Right, because this is gonna be true for all the boards by the time we get there. Only ones that are not currently finished, so. Okay, there we go. There we go. Right answer. Gold star. Awesome. Cool. That's fun. Well, that was. I wish I could think of a way to do that a little more elegantly, to share a little bit more code between the part 1 and part 2, but it was a fun puzzle. That array transpose is a nice feature that I don't know that I've ever actually used that outside of a programming puzzle before, but it's good to know. It's certainly handy for this kind of puzzle where you can save yourself a little bit of effort by doing that. I should be back again tomorrow night, right around 9 p.m. I'll usually go live a couple of minutes before. So yeah, thanks for everyone for coming out, and if you're watching this on YouTube, thanks for watching it, and see you tomorrow.